comments, input, output, and errors. Welcome back to Learning with Merritt. I am Mr. Merritt. It's time for your first baby steps in programming today on Python Interpreter. In Python, if we need to make a comment, we can do that very easily. First of all, we have a single line comment where we use a hashtag. If we need to make a multi-line comment, we can use the triple single quotes, and this makes a multi-line comment called a docstring. Or we can also use triple double quotes to make another type of docstring just with double quotes. Say that we have some code that we don't want to get rid of, but we don't want to execute. So we can highlight this right here, and we can hit Control// on VS Code, and that will make a bunch of single line comments. This now means that this code will be ignored and treated as a comment. If I hit Control// again, it will remove the hashtags, and now it is treated as code again. Let's say that I want my program to output something. We're going to use the print function call. So we're going to use print and then some parentheses. Inside those parentheses, in this case, we're going to put a string. Strings are text and they require quotes, so we're going to put double quotes. And then inside that, we're going to put the text hello world. If I save that and go to my terminal and type python main.py, okay, making sure that I am in the right file path, which I am here, and I hit enter, you will see that it outputs to the terminal hello world. Say that I want my program to accept some form of input from the user. So we can do that very simply. We have an input function. So we would type input and then parentheses like that. We'll go ahead and save our program. I'll come down here, type python main.py, and you will see that nothing outputs. But you notice that the prompt, which is this part of my terminal here, did not come back to me. And that's because the program is currently waiting on some input. So if I type hello and hit enter, I get the prompt back. Let's expand upon our input function. So if I want to provide the user a way to know what to type in, we can provide an argument here. So input, inside of input, we're going to put quotes because we want to provide a string. This string is going to say type some input. Then finally, I'm going to add one little thing, this \n character, which is to put the cursor on a new line. So that is called a new line character. If I save this and we go down to our terminal, we see where we had just typed python main.py. Now I'm going to do it again. This time it's going to ask for some input. So it says type some input. And then I'm going to say hello space world and hit enter. And it accepted that input. Finally, we're going to combine this with a print statement. So if I type print here, and inside of that print, I take the input function that we just did. This is called nesting a function call because print is a function call and input is a function call. And what it's going to do now for us, whenever I save that and open up the terminal, if I type python main.py, it will ask me for some input. I will type hello world. And this time, it will print hello world back out to me because it took my input and it printed it back out. One thing you may notice whenever you see me working with some of this stuff is if I hover over a function here, it will actually give some information about that function. This is just one of our extensions trying to help us out with our writing of code. And maybe you don't understand all this right now, but in general, what it's going to tell you is what the function does. Here it says prints the values to the stream or to the sys.standardout by default. That is when it prints the output to the terminal. And then we have the parameters here, which are sep, end, file, flush, and of course it also accepts values, which are the things to print out. And it explains what those are. So if you ever see that, don't be alarmed. It's just there to help you understand the functions that you're using and what they do. Let's talk about the common types of errors that you may run into. The first and most common one is going to be a syntax or compile time error, and here is an excellent example. Here I have typed print hello world, but unfortunately I have an error. Now, since we have tools to help us with this, it's already doing a little squiggle line here, and it's saying print is not defined. Now, if you were to run this, let's say we didn't have the tool. First, I need to make sure that I save. If we didn't have the tool, and I executed the program, what you'll see is we'll get an error here in the terminal. So this gives us the traceback. The traceback is your best friend. Here it's going to give you the file that you're looking for. It's going to tell you what line to look at. So we're looking for line 5. Here we are, line 5. We're having an issue. In our module, that's just the file, right? And then it is trying with these little arrows to indicate where the issue is. And then it will give you some sort of Python defined error. So this one says name error, name print is not defined. And then it will try to help you. It's not always going to be perfect, but it will try to help you. Did you mean print? And in this case, we did. We did mean the lowercase p print. And we save that, and when we run it again, it fixes the problem. So that's a syntax or compile time error. You have written something incorrectly based on how the language expects it to be written. Let's talk about runtime errors next. Now, runtime errors are going to occur probably second most commonly. Whenever you deal with runtime errors, your code is syntactically correct. So let's start with that. The first thing we need to recognize is that my code right here is exactly correct. So I've done print 5 divided by 0. This is syntactically correct. You'll notice that I have no squiggle lines or anything like that. The computer is not saying, hey, what the heck, this is written incorrectly. But if I run the code, I do python main.py here, it will actually give me a traceback and a 0 division error. Now what this means is this is an operation that the computer cannot perform because anything divided by 0 is technically undefined. So we don't really know how to handle that with our computer and our programming language here. So it's going to return an error and say that we cannot divide by 0. So this is a runtime error. All right, let's talk about logical errors. Logical errors occur when your code is syntactically correct and all the operations that you did were possible, but your code isn't doing what you expect it to do. So here's a great example of that. Let's say that I have the first 8 powers of 2 here. That's my goal. I want to print out the first 8 powers of 2. I don't want to have to memorize them. I just want to be able to print them out. So we've got 2, 4, 8, 16, 32, 64, 128, and 256. We're skipping 2 to the 0 power, so this is 2 to the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, and 8th, right? Now, a common thing you may think to do is, hey, well, that's super easy. I'll just use this little caret symbol here. So I'll say, this is also known as a circumflex, by the way. A lot of people call it a caret or a circumflex, whichever you prefer. But they'll be like, hey, this makes sense because this is how I do it in, Google Docs or on Microsoft Word or whatever to make it look like it's a power. And maybe that makes sense to you. So we'll go ahead and do that. We'll run that code. But when we do that, instead of 2, 4, 8, 16, we're getting 3, 0, 1, 6, 7, 4, 5, and 10, which makes no sense. And it's like, it's not doing what I expected it to do. Well, the issue here, ultimately, is that that is not what this little symbol is for. In fact, this is called a bitwise operator, and this bitwise operator is XOR. Now, maybe you don't know what that is yet, but it's definitely not exponentiation or powers like we thought it was. So the simplest solution is to figure out what's the actual operator here. And in this case, the actual operator is 2 asterisks or a double star if you prefer. So we go ahead and we will move this up and save it. And let's see if this works instead, does exactly what we want it to. So type python main.py. And when we do that, we see we get 2, 4, 8, 16, 32, 64, 128, and 256. This is by far the hardest type of problem to deal with. And one of the things you might do is use something called a debugger. So here I have, over on the left-hand side, we have run and debug. I'm actually going to set a little point here. We call this a breakpoint. And when I hit this run and debug option, it's going to keep track of some information that's going to go on. And first of all, it's got to actually run the program. So it's going to run the program, and it's going to stop me right here at this point. Now, the debugger is great for this because I can keep track of sort of what's going on. So far, we've only output 2. And then I can just have it keep stepping. So we're going to keep step, then it's 4, then it's 8, 16, 32. And I can step by step go through my program and look at certain things. We will be using the debugger more later.